So if you see this term even in a textbook, or if you find it randomly in a tutorial, all right, van der Waals is the same thing as London dispersion forces. All right, so this is going to be the weakest of the intermolecular forces. Put that in. Okay, weakest intermolecular force. There is an exception for later. Probably won't address it today. Probably save it for tomorrow. Okay, now, as I mentioned, pay attention to the interaction between two species. Now, the reason I say species over here is that it's possible in this category to be comparing just two atoms instead of two molecules, or even more complicated, one atom with one molecule. All right, so since there are many options here, the main thing is to keep track of just the interaction between the two species. Don't worry about what the species are too much. Okay, so what I'm going to start off with is just taking a look at two atoms. Okay, so example, two helium atoms, and here's the thing. We wouldn't expect the helium atoms to have any kind of interaction between them because helium's a noble gas. All right, so we don't expect helium to form any bonds of any kind, and we don't expect helium to have any kind of attraction with another molecule or another atom of itself. Okay, so in order to focus on a helium atom here, what I'm going to first do is draw a reference and then take a look at what this dispersion force is referring to. Okay, so for reference, we know helium, I have to draw a diagram where we have two protons. Okay, and then both of helium's electrons are found in the first energy level, so I'm going to just draw a circle indicating the first energy level. Now, two electrons, huh? These two electrons, you can place them however you'd like, but for the time being, I'm going to put the electrons far away from each other to minimize the repulsion. Okay, so we have two electrons, one there, one there. Now, here's the situation. These two electrons that are found in the first energy level, all right, the old atomic model would have been these electrons are orbiting the nucleus. Okay. The newer version that AP wants me to explain it by is that these electrons are not in a quote-unquote fixed position. Okay, these electrons, rather than orbiting like planets, these electrons are actually set up as clouds. Okay, and these clouds indicate probability. Oh dear. So here's the situation for us in terms of understanding what's happening. There's no guarantee that the electrons are in this position. Right? Instead, we know that the electrons are somewhere in the first energy level. We don't know exactly where at any given point in time because there's this weird Heisenberg uncertainty principle thing. Don't stress over that. Okay? Just go with the idea that the electrons are not going to be in the same position when we look at it.